All right, gang. So gonna do 8-6 today, which is over rational equations. Our learning target is that I can solve rational equations, and so you'll see kind of ones that look physically similar to our examples, but kind of a mixed bag on our strategy. But kind of to turn it into an equation that we're used to handling, like a linear equation or a quadratic equation. What we want to do, or I guess the big two steps would be to find the LCD and then multiply by the LCD to clear the denominators. Okay. Once we have no denominators, then life is, like I said, a little bit easier. We either have a linear equation or a quadratic equation, and it should be pretty simple from there. I guess this is also, I would also say this is important because we can end up with some extraneous solutions, like if we have a denominator that's 0 or something like that when we plug in. So you want to just be careful there. So anyways, let's go ahead without any more introduction and just get to it. So A has x plus 30 over 12 plus x over 6. And I know those x's look different, but let's just assume that they're both the same, and that's equal to 1/2. So on this one, we have kind of 3 fractional parts, right? So what we want to do then is try to eliminate all of the denominators. So we think about an LCD. And we could, factor out 12 and 6 and stuff to see what the LCD is. But when it's just constants, we normally can just see that. So in this case, our LCD is going to be 12. So that means that if I multiply both sides of the equation by 12, I should end up with no denominator. Okay. Now the next key is, how do we do that, or how's that look? So I think on x plus 30 over 12 times 12, that's easy, right? If you have something divided by 12 and then you multiply it by 12, obviously those just cancel each other out. So we're left with x plus 30. Then maybe it gets a little bit tougher if your denominator is not 12, but I just think about it this way. 12 over 6 is 2, so I just multiply the numerator by 2, right? So that would give me plus 2x. And then on the other side, we just have 1/2 times 12, which is just going to be 6. All right, at that point, it should be easy, right? So that's the key step. So anything kind of sticking out as like, that didn't make sense, or anybody have any immediate questions on that step? All right, let's go ahead and solve from there. I'll kind of solve the rest of the way without really talking too much, so you can solve on your own or follow along. But that is definitely the key step, what I've shown. Okay, so I'll solve the rest just kind of quietly, so you can practice on your own if you choose to. All right, so generally speaking, I think it's pretty safe to say if you solve correctly and there's no variables in the denominators, it should be correct. But just going over like how that would look to check our answers, it looks a little bit different. It might be a little bit tougher. We might spend a little more time on this tomorrow, but obviously, you just sub back in. The issue here is we have fractions when we do. So anyways, what we would get when we check would be -8 plus 30, whatever that is, over 12, plus -8 over 6 is supposed to be equal to 1/2. So if we think about that real quick, we'd have 22 over 12. And then let's make the other one over 12. So that'd be plus -16 over 12. So then you add those, you get 6 over 12, and 6 over 12 is equal to 1/2. So it's not super easy to check your work, but you know, that does still confirm our answer. All right. So let's go ahead and try another one. We're going to skip B for now, and we're going to go to C and D.
Have a good day.
Thank you. You too. Yeah, all right, so like I said, we'll come back to B and look at C. So on C, let's just take the same approach that we did on the other one. So my LCD on this one is just going to be, you know, 22 times 5x minus 22, which is kind of weird looking, but we'll just leave it like that. And let's go ahead and think about multiplying both sides by that weird looking factor and how that would work. All right, so looks complicated, but you know, if we can use some generalizations here, it's not going to be too bad. So if we think about multiplying this by our LCD, the 5x minus 22s basically cancel each other out. So all we're doing really is taking 22 times 2x plus 1, right? So we'll just distribute across there, and that's going to give me 44x plus 22. And then on the other side, again, looks kind of complicated, but you know, the 22s cancel each other out, so then we're left with 7 times 5x minus 22. Okay. What would that be? 140 plus 14, 134, I think, or 154, 154. 154. All right, and then we just go and solve for x, right? So subtract 35x from both sides. That would give me 9x. Maybe subtract 22 from both sides. That'd give me negative 176. And then I don't think 9 goes into 176, so then we just write that as x equals negative 176 over 9. Just to save a little bit of time, and this is something that I can show tomorrow, but you know, just imagine how tough that might be to check that answer, right? But we could, right, given a calculator, we could definitely do that. But we'll, just to save time, we won't do that today. We'll skip that part today. Now, did anybody have a different thought on how to solve this one? Like, there is a different approach that you've seen in the past. And you can see that D is kind of constructed or put together the same way as C. Did anybody have a different thought on, like, maybe not multiplying both sides by the LCD? What else could we do? What other approach could we take? Yeah, we could just cross multiply, right? These are basically the old proportion problems that you've seen before, like in Algebra 1. But remember that equal ratios have equal cross products. So you could also take this approach. This would be another approach on these. So if you take 7 times x minus 5, you get 7x minus 35. 3 times x minus 15, you get 3x plus 45. Like I said, minus 15. Plus 15, and then you go from there. I won't even bother solving from there. But that would be another way that you could think about it. And in either way, though, you're doing the same thing, right? So if we think back to the example we just did, if we would have used cross products there, we would take 2x plus 1 times 22, which we did, right? And we would take 7 times 5x minus 22, which we did, right? So either way, we're doing the same thing, just two different ways to meet the same ends, I guess. Okay, so I'll hold off on finishing D. You can feel free to do that on your own, but that'll be on the filled out note. So before we go to the back side, I do want you to try B. So notice B is put together more similarly to A, right? So cross products wouldn't apply because we have 3 fractions, not 2. So you do need to use that LCD approach, and I will call on you guys. So feel free to check answers, compare answers, all that good stuff. And try to be ready. If you got a common denominator, you could. You could, but you would need to get a common denominator to be able to add those together. Does that make sense? Yeah. So you can do that. Yes. Good question. I thought you had your hand up. Yes. All right. Mm-hmm. So like, I mean, if you thought about it like this without, so you know, if you took 12 times the 12, that would just be 12 times 6, right? And then, you know, that's just, yeah, that's 2. No, we're not. You could take that approach to get the, you could, you know, you could try to get a common denominator, but that would just be, you know, we're kind of trying to cancel out the denominator. But you could do what you're saying. So we're doing something. Yes. Well, we're looking at, sorry, we're looking at this letter. That's all right. Yeah, we're just looking at the front side letter B here, guys. That's what we're gonna go over. Sorry. All right, so kind of walking around, it looks like people, the general population is having a little bit of trouble. Here's what I'm seeing. People are okay with coming up with the LCD and then multiplying both sides by the LCD. So people are understanding that we need to multiply both sides by 35, but then they're getting stuck after that. Can anybody tell me what you end up with after we multiply both sides by 35? Can anybody just tell me, and then I'll kind of explain it? Reagan? Well, that's going to be the final. That's going to be the final answer. Yes. But can anybody tell me like what we get when we distribute like the 35? But yeah, Reagan, you did it right. Good job. So 5 plus 5. Right. And then 1 is 7. Well, 7 times 1. Very good. All right. So again, just think kind of fraction by fraction here. Okay. So if we take 35 times, 2x minus 9 over 7, right? Just focus on this part. Then think about, just think about 35 over 7. What's that equal to? That's equal to 5, like Shrieker said, right? So I don't know if you want to write that out, but this would be 5. We're really doing 5 times 2x minus 9, okay? So 5 times 2x minus 9 would be 10x minus 45, right? And then the next fraction's a little bit easier because you have just 35 over 35 is 1, right? So then I'm taking negative 19 times 1, or just minus 19. And then on the right side, think about what's 35 over 5. That'd be 7. So then we're taking 7 times the numerator, right? 7 times the numerator. So that would give me 7x minus 49. So that seems to be where we're struggling, and that's where you would struggle. That's kind of the new step. So does anybody have any questions after I talked you through that again, or it kind of start to make sense? Yes? Well, we did multiply both sides by 35, and so I would just ask you to compare just in general after we did that. Which version of the equation would be easier to solve? Would the top version be easier to solve, or the next version? Well, we multiplied everything by 35, but if you think about, so just think about this first one, okay? So if we take 35, we're taking 35 times everything. So if we take 35 times 2x minus 9 over 7, basically what I'm doing is I'm kind of pre-canceling, right? So 35 is just 35 over 1. Agreed? Right? So then we can kind of cross cancel, right? So this would be, if we divide everything by 7, that would be 5, and that would be 1. So that's how we end up with 5 times that. Does that kind of make sense? Okay. All right. So good job asking questions. And then hopefully everybody's kind of got it from there. So I'll go, I'll work the rest out quietly. If you haven't already done so, you start to do so, and then we'll compare at the end. We already know that the answer is x equals 5, but how to get there, you need to make sure you know how to get there. All right, so any questions about solving once we get rid of the denominators? All right, so moving on to the backside. All right, so let's skip over A. If we have time at the end, I'll leave that one for you. I suspect we might not, so we may come back to that tomorrow. So let's focus on finishing with B and C, and that'll be, we'll call it a day after that. Okay, so skipping to B on the backside, B on example 2, we have 3 over x plus 9 plus 5 over x minus 4 equals 57 over x squared plus 5x minus 36. So it looks like a handful, but if we factor, if we factor our quadratic, it might get a little bit easier, okay? So does anybody know what that factors to? There's a clue within the problem. 9 and negative 4, right? So x plus 9 times x minus 4. So, like, why do we need to know that? Well, now we know the GCF is not x plus 9 times x minus 4 times x squared plus 5x minus 36. We know that really, either one of these is the GCF, okay? So either one, we can think of either one as being the GCF, all right? When I show my work here, I'm going to show it as x minus 4 times x plus 9, though. And I think it'll be easier to think about multiplying that way. All right, so we're going to multiply by x plus 4 times x minus 9. Sorry, I said that backwards. Reversed my signs. Let's try x plus 4. Said it again. X plus 9 times x minus 4. There you go. Third time's the charm, right? All right, and then on the other side, we could just write it the other way if we wanted to, because they're the same thing. All right, so when I multiply here, think about it fraction by fraction, right? So the first fraction, the x plus 9s are going to cancel each other out. So what am I really multiplying after that? I'm multiplying x minus 4 times 3, right? X minus 4 times 3 is what I'm left with after I cancel. So that'd be 3x minus 12. Then the next fraction, we're taking 5 over x minus 4 times our LCD, right? So the x minus 4's cancel each other out. So what we're really doing is taking 5 times x plus 9, okay, or 5x plus 45. And then on the right side, the denominator is the LCD, right? I wrote GCF. See, I'm all out of whack on this one. I meant to write LCD earlier. Sorry about that. But yeah, all we'd be left with on the other side is simply 57. Again, that's the key step, right? So should be simple after that. But does anybody have any questions on that multiplication? Getting rid of the denominators? Okay, well, I'm going to go through and solve for x then. If you think of anything that seems confusing, you just let me know. All right, so we get x equals 3. Now, I will say that it's probably a little more important that you check your solutions, especially if you have variables in the denominator, okay? And it's not super easy to do, but let's see what that would look like, okay? So we're checking, does x really equal 3? All right, so going back to my original equation, 3 over 3 plus 9, that'd be 3 over 12. 5 over 3 minus 4, that'd be 5 over negative 1. And then that's supposed to equal 57 over 3 squared plus 5 times 3 minus 36. So let's think, what would that be? 9 plus 15 is 24. Take away 36 would be negative 12. So hard to tell if that's true or not, right? You know, but if we look at, I don't want to get too into the weeds here, but if we look at that as over 12, that'd be like negative 60 over 12, right? So negative 60 plus 3 would be negative 57. Right? So those are going to be equivalent, and we can tell that x equals 3 is, in fact, a valid solution. Okay? All right. So take a deep breath, and let's do one more. And then we'll spend some more time on this tomorrow. I can tell that some of us aren't all the way there, but hopefully you feel like you're at least kind of getting there. Okay, you don't have to have it after a couple of examples, right? All right, looking at C real quick. Let's go ahead and just knock it out how we have been. All right. So my LCD overall, does anybody see it? Yes? X plus 2 times x minus 1. That's right. Good. All right. Now, kind of fraction by fraction. My first fraction is its denominator is the LCD. So I'm just going to be left with the numerator. My second fraction, x plus 2's are going to cancel, so we end up with 2x times x minus 1 after that. So that'd be plus 2x squared minus 2x. And on my last fraction, x plus 2's cancel, so we just end up with x minus 1 times x minus 1. So that would just be, if we kind of think through it, it would be x squared minus 1x, so minus 2x. And then plus 1. So obviously this one is different than what we've had so far because we have a quadratic, not a linear equation. So sometimes that can happen, right? So just to review, we know several ways to solve this, but first thing we need to do is get it in standard form. So let me simplify the left side, then I'll rewrite it in standard form. So left side's equivalent to 2x squared minus 1x minus 1. And then we either want to move all the left terms to the right side or vice versa. Since I want my lead coefficient to be 1, I'll kind of move these terms over there, right? So that would give me 2x squared minus 1x squared, which would be 1x squared or x squared. Negative 1x plus 2x, so that'd be plus 1x. And negative 1 minus 1 would be negative 2. Then we're in standard form. Okay, I like to factor at this point. If you're not super good at factoring, you could think quadratic formula. You could plug it into your calculator and look for the x-intercepts, right? There's several things we could do. I think factoring just tends to be the easiest. So this factors to x plus 2 times x minus 1. And then we can use the zero product property from there to come up with x is negative 2 and x is positive 1. All right, now we'll finish on this thought, and because this one's a little bit weird when we start to plug in. All right, so let's check the x equals negative 2. All right, so that's going to give me negative 3 over. Let's see, that'd be negative 3 times 0 on the bottom. Now, really, at this point, you can assume this solution doesn't work. Anytime you have a denominator of 0, really, you don't need to go on. All right. So if you wanted to plug the rest in, you would actually get all denominators of 0. So it doesn't really matter, though, after the first one. All right. So we know it's extraneous after that. All right, so then let's see what happens. Does anybody know what happens when we plug in x equals 1? Are we going to get a 0 denominator anywhere? Yes, right, on that first fraction again. So think about plugging in x equals 1. We would get 0. So this kind of is a little bit more interesting, I guess. We get 0 over 0. So that's the one case where we could keep going, but watch what happens when we do keep going. So plugging in 1, so we'd have plus 2 times 1 is 2 over 1 plus 2 is 3. So 0 plus 2/3, and then we plug it in on the other side, we'd get 1 minus 1 is 0. 1 plus 2 is 3. So is that true? 0 plus 2/3 equals 0? No, that's not true. That says 2/3 equals 0, so that's not true. So this is also extraneous based on that. So if both of our choices were extraneous, what do you think we'd say? No solution. Yeah, this guy has no solution. So that can happen too. All right, so I will have you guys take a quick break, and then we'll come back and finish up with how could we have approached this problem maybe in an easier way. So stand up, move around for a minute, and then we'll come back and talk about just maybe a more efficient approach and finish up that way. Okay? Take a break, move around, do something else, talk. Try not to just text on your phone. That's just lame and antisocial. Yes, just sign out.
Would you have the notes for 8.4 and then the second page for 8.5?
I don't have physical copies, but they're all,
Okay.
you know where to find them on Google
Yeah,
Classroom.
we have the physical.
I haven't been printing them out this year, so, but if you, I'm happy to print them out, but